Hello everyone, thank you for joining us today. My name is Jennifer Byzantine and I'm part of the modernization team here at Invensys. Before we get started, I would like to make sure that you're aware of the modernization webinars that we're holding over the next several weeks. Today's topic is delivering sustainable turbomachinery performance, a critical asset to protect for performance. And with us today is Hector Buscelli, Director of Invensys' Turbomachinery Group, a group focused on delivering standards, tools, and control systems implementations for turbomachinery, control applications, and machinery retrofit solutions. Before I hand it over to Hector, I'd like to remind everyone that all lines will be muted, and there will be an opportunity at the end of Hector's presentation to submit questions. And with that, I'll now hand it over to Hector.
Good morning, everybody. I appreciate everybody's attendance. And we're going to talk today about turbomachinery and how we can improve what we'll be dealing with. Also, we have, when we're thinking about modernizing turbomachinery, we also have what we call the mechanical retrofit and protection solutions. In this particular case, we're thinking about machines that might be very old, maybe 40, 50 years old, and in some cases they have control valves that are very dated, that might have very old hydraulic systems, or even the old technology, the fly bolt, which was the first technology introduced to do governor control. In these particular cases, when we face turbines of that kind, we need to have a means to be able to interface state-of-the-art of new control systems into those mechanical devices. And that's when we can help at that point bring into you our mechanical retrofit expertise, where we can modify actuators and put indications and travel indication of the valves so we can have a proper interface at that point with your turbine. Also, it's very important to consider everything related to protection around the machine, specifically when we're considering the trip system, and see how the trip system is currently being implemented and what other things we need to improve or modernize to make more safe and reliable operation of your machinery. As you can see, the scope is very big. You might have a little piece that needs attention, or you might have the whole picture that needs attention. So at that point, it's very important for us to understand where the needs are and how we can help you identify the solutions that are best fit for your particular issues. Based on that, here in Invensys, we have created what we call a market segregation. And that means that we developed our solutions and services based on these main offering segmentations. We have compressors, that is basically the HPI market, everything related to refineries, chemical plants, ammonia plants, fertilizer plants, everything where the compressors are the main core of the application. We also have another segmentation where we based our solutions and efforts in power, and we have two for them. Would be what is basically the fossil power turbomachinery, and we have another segment that is basically on nuclear TMC. Nuclear in this case, even though it's also a power generation business, is separated given the regulations and the special kind of paperwork and standards that are required for implementation. Then we have another specific core here that we call mechanical retrofit that services all these other industries and segments, providing the interface that I mentioned before for adapting different kind of machinery to your needs. And we have another piece that is called the services. And services is very important for us because we use our expertise. We have folks in our group with many years of experience. We have people with 30, 35 years of experience, and we want to bring that value to you and show you things that you might not seen or things that you might not know that are new things that you can improve, or things that you have in your system that might not be working well that we can improve and really work on your bottom line and help you in that case. On the services piece, we have a lot of work or a lot of opportunity to serve you related to studies, tuning, process improvement, dynamic simulation, and many things around your processes that using our expertise, we can help you to improve those the things that might be working not that right at this point. Now, the good question that we want to really know is, why do we want to modernize? And to do that, I always like to show this example. This is an application that we did for a power plant. This is the main ram that was used on a feedwater pump. As you can see here with my pointer, this is a main ram here that, as you see before we modernized this particular turbine, it had all kind of mechanical links, all kind of pins, springs, knobs. As a matter of fact, it was called in the plant the mechanical nightmare. It was very difficult to control the speed of this feedwater pump, and as a result, this particular power plant couldn't control or couldn't improve the amount of megawatts that the plant could produce with their main turbine. So even though the problem seems to be that it's the main turbine that is not creating the power, in reality, the problem was the feedwater pump that, since they couldn't control the speed, they had a really difficult control for the boiler and the amount of water that was produced, and that created a lot of problems. In this particular case, we came in with our experts, and we determined the different things that needed to go away, and as you can see, many things went away, and we replaced the whole mechanical nightmare, as they were calling it, with a real clean solution with a high-pressure actuator that interfaces directly with the main ram of this turbine. And we put also position indication by the means of LVDTs, which is linear variable differential transformers. And then we can have a closed-loop control using our controllers. And then in this case, they were having a really nice control system and a really very accurate speed control. And in that case, they could load their main turbine to the amount of megawatts that the plant was designed for. So this is just a little example of things that we might have in our plants today, and where we need some help and maybe identifying what can we do to make things better, to improve my efficiency, my reliability, and my availability. So one of the things is why we want to modernize. And as I said before, turbomachinery is a big investment, and it's a very concentrated investment. Not many facilities have spares. I've seen in many, I've been working on turbomachinery for about 25 years, and it's very few plants where you can see I have 2 main air blowers, or I have spare hydrogen compressors, or things like that. It's a high investment, and it's the unique piece of machinery that we have there. So it's very important to maintain that. It's one of the most critical investments that a plant can make, and it's a good reason for it. If your turbine goes down, your plant loses millions of dollars per day in almost any business. It's very critical what happens when the machine goes down. Also, turbomachinery is technically complex. It provides essential process pressure, flow, and energy transformation. Most of the time, the turbine and compressor pair is the core of your process. And like any other complex piece of machinery, from this compressor that I mentioned or this water pump that I mentioned before, to the mobile phone that is supporting your life today, it needs to be updated to be effective and safe. Just imagine trying to do your job with a BlackBerry or an iPod or something that is 10 years old, and you might survive, but you know that what you'll be missing with the new technology that is available to our hands today. Same thing applies to turbomachinery from years ago. Our turbomachinery from that time still works. Many facilities that have systems running for 20 years in manual, and I've seen that many places. But modernizing is a must if we want to really improve and make our plant work better every time. Now, you might have concerns, right? It's okay, I have a plant, I might have issues, but where do I start? What do I need to do? How do I minimize my cost and risk? How do I justify the necessary improvements? How do I sustain and maintain the improvements? And how do I track my progress, right? Those questions that probably come to mind all the time, saying, why or how do I start doing this a reality? And then come here and says, why using us? And many folks and many customers and many people that have worked with us might know the expertise that we have, the amount of people that have many years in this business that understand your needs and can help you. And the main idea here is that we want to work with you, be that trusted advisor to help you identify what issues you might have and give you a plan and a roadmap how we can help you to get your machinery in a better way every time. So we can help you with obsolete components, analyze trip history and see what happens with spurious trips or any other conditions that you might have. Help you with adherence to machinery standards. Right now, standards are changing dramatically day by day, and we're up to date. We have a life cycle group that is just working on those kind of standards to help you be compliant with many regulations that are happening in the industry today. We'll also help you with what is going on with mechanical part malfunctions. What happens if you have really customized pieces where you cannot find any spares? How can we help you with that? And obviously, reliability and availability, helping you identify that you might have continuous trips due to parts that don't work well or things that are not tuned properly. And as I said, finally, help you also to tune your system. Sometimes you might have top-of-the-line controllers, but if the system is not properly tuned, then you might have all kind of upsets. And you will see the upsets when you have changes in your process, because that's where the proper tuning comes into play. With everything stable, any tuning will work fine. But we want to be sure that any other situations where the tuning needs to be on check, we're ready there to help you. That's a survey question here.
Okay, thank you, Hector. We are actually going to ask a quick question and poll the audience here. So please take a moment to vote. The question is there a mechanical overspeed system with your machinery? So please vote either yes, but they're obsolete, yes, or no. Just give you a few seconds here. Okay, Hector, it looks like it's split evenly.
Okay.
A third have voted on each, so hope that gets you the information you need. Go on.
Very good. So that question was asked because after talking of all these things, now we're going to try to talk more specifics. And basically on this particular presentation, I want you to have a special case, and that's an evident problem that we found in a facility, and we've seen this in many facilities where they have a very aged existing trip oil system. And one of the things when that happens is we need to investigate what issues or what problems you might have related to that trip oil system. And we have questions we can go and ask. For instance, does the site have a 2 out of 3 voting scheme, or do you use simplex systems, or just one transmitter will give you the indication, or you have redundancy? What is your scheme? We will touch on that later on. In this case, if your turbine has already an electronic governor, it would be nice to know how many speed probes or pickups the system currently have. And that's important to determine if we're going to upgrade to an electronic overspeed system, what we would do with the existing speed probes, what has to be added to it, what do we need to do to comply with standards. So that's one of the questions there. And does the system have many pressure switches for trip action? That's very typical to see in all machines, where still the trip system is based on switches. And even though they're reliable, after many, many years of usage, they start becoming less and less reliable, and you might have a serious amount of spurious trips, especially if they're in a simplex configuration. The question that was brought in the survey is if you have a mechanical overspeed system. And that's one of the things that we have been addressing a lot lately in many plants due to the cumbersome approach to mechanical overspeed in the sense of testing, in the sense to be sure that it complies with your insurance requirements, in the amount of time that sometimes it takes to do your testing, especially when you're ready to start the machine up, because with a mechanical overspeed system, you have to actually take the machine to the mechanical trip level, and if for any reason it doesn't work, then you have to shut down your system again and work on it, and many times you have to allow the machine to cool off and things like that, and that takes time that is impacting the your startup or your outage time frame, and it's also impacting the amount of product or operation that you have on your machine because you're delaying your actual startup. And how is the trip system configured? Do you have a separate control oil from your oil system? Is isolated? What kind of filtering do you have? Many questions that might be part of that. So I'm bringing those things to give you a frame or how we work into a modernization assessment. So we have components that we have established into what we call the modernization roadmap. We have the workshop, and I will be talking a little bit about them later on. Basically, we're going to have a workshop where we want to talk to you and investigate and help you identify what problems we might have or you have in your facility, or things that you haven't know or that you don't know that might be a problem. So this is a one-on-one relationship where we want to help you identify problems and also hear from you what problems you're experiencing right now where we can help you. Based on that, we will work on a full assessment, which is going to be a solution that we're going to be presenting to you on those problems and how we can tackle them to help you. Once the third phase, once this plan has been accepted and is in your budgeting and in your cycle, then we go and do everything related to the design and implementation, where it's going to be basically, depending on the modernization upgrade that we're working on, it might be your mechanical retrofit piece, it might be your documentation, your control system, your dynamic simulation, your study. It depends on what we need to do at that point to help you. And then after that, we need to work on how to manage and sustain the solution that has been presented to you. What is the life cycle of the systems that you're getting? What kind of upgrades you're going to be having? How the system can be improved as years pass? What things can we add to it to make it more reliable every time once you have done your modernization? So those are the main core components of the modernization. And today in this presentation, we're going to focus mostly on the workshop and the front-end piece of this package. So let's analyze your needs in terms of resources, scope, and deliverables. This is a very important piece to understand what we need when we're working on a workshop. So basically, as resources, we have sales consultants. Within Invensys, we have a group of individuals called product sales executives, which are people that are experts at a product level. We have also technical sales consultants with experts at the technical solution. Obviously, we have our sales force, and backing all them up, we have a great delivery, turbomachinery, lead engineers, and consultants that are also backing them up to help you facilitate an environment where we can dialogue with you and explore machinery issues, production goals, budgetary cycles. These are the kind of people that we need to get involved. On your side, we're going to be requiring all bringing the proper stakeholders that are part of your process. Maintenance people, operations people, operators are very important folks requiring to hear. Even your financial team is important so we can understand and you can understand how things can be implemented. What is going to be the scope? Basically, we want to create the awareness of the TNC modernization needs that you might have and address how our services and solutions might be improve the reliability, availability, and performance while minimizing the risk. This is the main part. How can we do this modernization in a way that is minimizing your risk for future operation and as you do your upgrade? So this phase focuses on increasing, showing to you maybe other cases, other facilities or other circumstances where we have done something similar. So you can also have a credibility of what we've done. That is not the first time we've done this for many, many years. So it's important for you to understand what we do, probably have some referenceable experience, and we might have different interfaces with you at this point. What deliverables we'll have after this workshop? So the main focus, we're going to have interviews. We're going to talk to your people. We're going to have exchanges. We might have presentations of what we can offer. You might even have presentations from your plan. Let us know history of problems that you had in the past. We can talk about install base. We can talk about return of investment, which we understand sometimes is very difficult to justify an investment, and we help you trying to model what investment could be. And also, we can work on proposals and studies to give you an idea of what can be presented as a deliverable for this workshop. So let's look at the big picture here. When we're doing the site visit, and this can be many site visits, it can be one of many. One of the things that we want to do, as I said before, is bring together the main stakeholders and define the problems. Discuss machinery and control issues. So this is a really good conversation to really understand what is obsolete in your plan, what kind of improper operation you have. Do you have trip history, causes, lack of information? The operators don't know or that don't have the ability to get all the diagnostics that they want. You might have no adherence to machinery standards. There are malfunctions in mechanical parts that sometimes you have to go manually try to make it work. You have reliability and availability deficiencies, like continuous trips or process upsets that you cannot really control well. And obviously, we can talk as well about improper system tuning. In order to do all that, we also collect information. And what that information might be will be in the sense of PNIDs, so we can see what your structure is, startup curves, steam maps, compressor surge maps, documentation related to your existing instrumentation, valves, cross-sectional and control triple oil diagrams, so we can really understand how the system might be, how obsolete your components might be getting, and how we can help you with that too. Another piece that is important is the communication architecture. I've seen many cases where people have good machinery, they have good systems, but they lack a proper communication interface. So most of the time, operators might be completely blind on diagnostics or an important information where they can do some preactive actions instead of waiting for an actual failure. So we can help you too to analyze your HMI interface, your DCS interface. We can work on peripheral or third-party interfaces like vibration systems, monitoring systems, condition monitoring, and other things where the operator interacts day by day and help you with that as well. Also, we have developed, and it's one of the things that are new, we have developed a modernization worksheet. And that modernization spreadsheet is very nice because it allows to move our customers and you specifically into the different things that we might need from you in order to give you a good understanding of what you have, what you will be able to have by improving your system. And it's a really nice questionnaire on all the different things so we can really have our hands around the whole machinery, including, as I explained before, from the mechanical piece to the communication layout, and give you a much better idea of what we can do for you. I have another question here.
Thanks, Hector. Okay, I'm going to launch another survey question, so please take a moment to vote. You only have a few seconds. What is your biggest turbomachinery problem? Dealing with obsolescence, avoiding spurious trips, adhering and complying to standards, or improving instrumentation reliability and availability? So I'll just give you a few seconds to vote. Okay, so it looks like, Hector, you got 50% saying avoiding spurious trips and 50% says improving instrumentation reliability and availability.
Very good. Okay. So the question was based on trying to understand how we design the solutions. Depending on what your needs are, the solution might have a different path. Okay? So as I explained before, we're identifying stakeholders, people that are part of the solution. We identify what needs you might have. And in here, for instance, you're talking about you have obsolete components or you want to avoid spurious trips. So we need to identify what is causing the spurious trips. All right? Once that is identified, then we want to say, okay, let's work on your budget cycle and develop specific development milestones that we might have to have here to help you implement the solution. Spurious trips might have many different causes. It might be from an improper tuning to parts obsolescence, to pieces that are not working correctly, to an operator that is not properly trained and is causing or is not following the procedure that is causing problems that eventually will give you the spurious trip. So there are many things that might be parts of that, and we work towards creating a solution. And then we work on a roadmap of how we're going to be implementing that solution that has a nice fit with your needs, your budget, and your cycles. In this particular case, if I go back to the example of the aged trip system, during that site visit, we determined that we needed necessary mechanical system upgrades to make the system more reliable. And one of the things that were identified was the importance at that point of having an overspeed protection system and removing the mechanical one that they have before. So one of the things that were proposed on this particular case was replacing transmitters. They have switches everywhere, so it was important to get into a newer technology where they have better availability of pieces, where they can have better diagnostics. And change the trip system configuration. It was very cumbersome, so we did an improvement on that. Also, we went into an electronic overspeed system in conjunction with a trip lock. So these two pieces work together, where we have a system called the Quadboarder in our portfolio that allows you to have a trip lock that is testable online, and that you can change pieces online, and that is easy to use. And all that together make a system a lot more available and reliable than what it was before. Also, we did an upgrade on the speed indication, improve the amount of speed probes that they have, comply with standards that were in place at that point for segregation of overspeed protection and control protection or control performance. And all that piece together has improved dramatically the way their particular trip system is working today. Now, there are many things, depending on what we find, that will have different costs, risk, and complexity. And depending on that, there might be different phases how we're going to be doing this job. For instance, if we go with the low end here, when we have low cost and low risk and low complexity, and it's something that we have to do quick, that you need some results, there's many things that we can work at that point. For instance, we can have studies done, assessments, where we can have a real good plan identifying what is going on with your instrumentation, how we can have a better, for instance, team balance in your plant. Do we need to improve the HMI? Surge control performance. What do we need to do to improve your control system? Capacity performance, governor controls. It's a lot of things in there that is low risk, that is just presenting to you the ability and experience of our people to let you know this is all the things we can do. Then, when we can go there, is that what benefits we can get out of that is that you can get, at that point, you can have energy efficiency reductions. You can improve your insurance, reduce the insurance costs that you might have by doing certain things. So there are many things that we're looking in that particular point that we can improve. If we go to a middle point here, is when you're going to have things that are more expensive and have more risk, but will give you more benefits. And at that point will be, for instance, the mechanical trip system upgrade that I just mentioned. In this case, you're replacing your mechanical overspeed ball, you put in electronic systems and everything else that I showed before. And that will give you a lot of benefits. It will provide to you online testing and services. You will have, for instance, to give an example, a fully documented package for customer ownership. I've seen many cases where documentation is very scarce. You might have documentation for your OEM that is very dated, that it does not comply with what you have online or on site. Many cases I've seen applications where you go to panels, and through the years they never have updated documentation, so you see wiring going all over the place that you don't know where it's going to. You see jumpers somewhere that you don't know what they're for. And that's a risk right there of a spurious trips. So we want to have all that fully documented package with demolition information and giving you back to today of what you have in your particular plant. That also allows to enhance your availability, reduce your insurance costs. Also in this piece here, we can have partial control upgrades. I've seen many cases and many facilities. I can bring one, like one we just did in Mexico, where they have a lot of issues with the surge control. And they only have the budget and the time to improve the surge control piece. And that's what we did. We improved the surge control system. We added performance control. At that point, we didn't do anything with the turbine controls or the speed manipulation, but just by improving the functionality of the recycle valves, allowing capacity control to be in place, that was a big improvement in their process. And it was a low risk, low cost solution that they needed at that point. So we really worked with them to see how that was fitting their piece. Another thing that is interesting that I've seen in many cases is to have, for instance, high-fidelity simulators. I've seen a lot of good results with these. I've seen many applications where the process is very difficult to control, and sometimes it's not that easy to tune. And when we have a high-fidelity simulation, it's very easy for our experts to do all kinds of scenarios and bring to you the best control scheme that will work for that particular application. I've seen many cases, like just to bring some information, like there are some plants in South America where they've been running for years, the surge control in manual, just because as soon as they put that in automatic, the whole system collapses. And it's basically because they might have, like for instance, they have quench control that is not properly done, so they have issues with the levels, start tripping the machine, they cannot control the system properly. But they run in manual. They believe it's good being in manual. They don't have the upsets. But if you think about having a recycle valve open for 20 years, that is increasing your steam consumption by some percentage. The amount of dollars that you have spent is really significant. So that's one of the things that you have to put into consideration. Yeah, I have a control system that is in manual. It is okay, but that's not the way to go. You can have a proper tuned control system that is going to give you all the efficiency of your machinery, that at the end of the day, you're going to save a lot of dollars when you're considering the energy consumption that you're having on that particular machine. On the high complexity piece is when we go full blown, right? When we do completely mechanical retrofit work, like the one that I showed you on the first picture, when we replaced the main actuator, we might go into a high pressure solution. We will put with hydraulic power units. We will have independent control system from low oil system. But then you will have everything. You will have a full control upgrade where you can have like integrated turbine control with compressor control. At that point, you can have all your control algorithms working together, giving you the best possible control system that you can have. You can have your speed control, surge control, plus a decoupler control, so you can balance the amount of influence that your speed control and your recycle valve can have on your performance. And at the same way, you can have the same type of approach in a turbine generator integrated control, where on the same package you can balance all your algorithm to maintain your speed, your power, your megawatts, your isochronous control, your load sharing. You can have an automatic voltage regulation in the same package, where at the same time you can control power factor, megabars. You can do strategies for load sharing where you have different units, and then at that point you're using the full-blown capabilities that we can offer to you to help you. Coming back to the example that I had on the overspeed, I'm going back and forth into the general and going back to this specific case. On this particular application, one of the main things that they wanted to have is the ability to have online testing and service. If you have a trip system, even if it's redundant, obviously if it's simplex, you cannot do anything with the trip solenoid. It's going to trip you if you have to try to do anything. But even if you have redundant systems, and they're in series or in a configuration that you have 2 out of 2 or 1 out of 2, then you have to have a special kind of things to be able to do online testing, and most of the cases it won't happen. Even on systems that I see that are 2 out of 3, or even very complex systems, if it's not easy to use by the operator, it will not be tested. the operator won't go to the field and is not going to move valves with confidence, knowing that if it makes a mistake, the system might trip. So one of the things that we've done in these kind of modernization efforts is that we have created a really standard package that the only thing that the operator needs to do from the HMI is to push a button which starts the cycle of testing all the trip solenoids that are part of the system. We have all the interlocks in place that if any valve of any parts of the test are not being, they don't pass, immediately the test is aborted. They got all kind of alarms. They can identify if a solenoid is stuck or is not working properly, and they can do, at that point, online replacements. And this is very important. We have done that a lot in nuclear facilities where they really need to have at least a weekly test of the trip system, and it's been very effective for them, as well as getting all the documented, all the package, all the documentation, and having all the diagnostics of what they need to do to fix any particular problem they might have in the trip system. And obviously, when they do that, they can reduce dramatically the insurance costs. They can justify that they're doing a weekly test and things like that. That has some financial impact. What makes us an important player here for you? We have the experts. This is a main thing. I've been in this business for a long time, and you can tell we have one of the best people in the field. We can identify your problems. We can work with you. We have really good relationships in many facilities around the world. You know how we can interface with your people. And this is just a summary of everything that I have said before, how we can do interviews, do site visits, work with the modernization worksheet, share other opportunities that we had with you so you can see what we've done in other places to help you. We take pictures. Sometimes we need to make an assessment on many mechanical pieces that we need to replace, but sometimes we cannot do it because the machine is running, we cannot trip it, we cannot have measurements, but we can take pictures. We have the expert that out of pictures can determine what could be the best solution for your application, and we've done it many times. Work with interface with your operators, build graphical interfaces, and determine what signals you really need to have. Sometimes I've seen cases where you have so many alarms that just the operator gets just swamped on alarms and doesn't really understand or act on the real ones that he really needs to pay attention for. What else? The planning. How we can make the assessment, how we can work on all the different deliverables that might be part of that solution and help you go through that and say how we can put a time frame depending on your needs, your budget, and make it happen. So it's important that we have a planning. We don't want you, or we don't want you to go ahead and start doing everything at once or without a proper order or without tackling things in a rational priority depending on your needs. We want to work around your problems, your financial constraints, your machinery constraints, your operation constraints, and see how we can help you to get this solution. We have developed through the years a lot of templates and standards that allow you to minimize the risk. We have many control algorithms that we use many, many years. They're fully tested. We have all the documentation related to the test of these blocks that is at any point can be shared with you. So you can see that these are things that we're doing for many years. As any other software that is in the market, we find issues, we fix them, we review them, we have a complete traceability of what has been done and improved, and every time we try to make them better and better. Sometimes it's not a problem, it's an enhancement that we're doing to the function to make it better based on the experience that we get every day in the field. Sometimes we see things that we can do better, we improve our logic, and we develop a new template, a new standard, and we check it out, obviously, very thoroughly. But at the same time, we also customize. We're not just going to tell you this is what you're going to get, period. No, we work with you as well to give you the best proper solution, not in a black box. It's open to you to work with us. You can see what is there. We can help you, and you can help us develop that as well to give you the best solution for your particular application. And finally, you have a roadmap. And that roadmap is when we're going to have how we're going to make your scope granular. And we can say, okay, we can do all these different pieces. We can discuss what are going to be the main priorities, and we can analyze the budget. So for instance, in a particular application, we might have a roadmap when we said, okay, let's do a dynamic simulation of what we need, and then we can assess the things that we're going to be changing. Let's work on first of all, let's do a trip system overhaul. I want to make that my first thing because I'm getting a lot of spurious trips that might be coming out of that. Let's also work on my instrumentation and my communication, and let's upgrade that to bring it to a point where I have good diagnostics, and I know that there are not going to be single point of failures there. Then let's work on a mechanical retrofit on my turbine that is very dated, and I need to bring it to the new standards. And finally, we can say, okay, and now let's bring my control system and get all these new integrated control algorithms to give me a state-of-the-art system that I know is going to run for quite a while. It's going to be supported. It's going to have standard parts that I can use anywhere. And I'm going to have a life cycle of all these that I know is going to be maintained by Invensys, helping me to achieve what I need on my machinery. I have another question here.
Okay, thanks, Hector. So our final question today is, what is your time frame between shutdowns? So just take a moment to vote. Your options are 2 years, 4 years, or 6 years. Okay, thanks, everyone. Hector, it looks like our respondents answered 4 years. So
okay, so that's the important point that I wanted to bring here, is that we work to really determine what these outage timeframes will be and how we can work on those different timeframes and what kind of solutions we can give you in those timeframes. There are many facilities that are thinking today on running for 10 years, nonstop. How we're going to work on with that kind of application, how we're going to give you systems that are going to be upgradable in the field, that you can run effectively for 10 years without a shutdown. And we work on that. We're working on new developments and things that will allow you to do that in the future. So that's important. You have a 2 years. Yeah, what can we do in those 2 years? If you have 4 years, the same thing. What kind of solutions we can put in those 4 years, and when you have your outage, we're ready to do it for you. We have done a lot of this work in many industries like fossil fuel, nuclear, HPI. I have one example here on one that we're working on right now for it's going to be a 10-year plan. It's a modernization effort for a fossil fuel power plant where they have a bunch of different issues. They have serious operations, problems with data. They don't have historical data to really analyze what's happening. Maintenance data is really difficult to find. And this is what we get as Invensys, helping you with many things that we have in our portfolio, like asset management, on how you can determine cycles for your maintenance and how we can help you with that. So while we were doing the focusing on the main problem that they have, and we were talking about different things that the potential problems that they might have, one of the things that we identified, now if I focus on the turbomachinery, was the mechanical overspeed system problems. There was something kind of hidden there given the other problems that they have as a whole. But when we start drilling down and digging with information, we found that the mechanical overspeed was very significant. We went down to different, to whatever history we could find on trips. They had a significant amount of spurious trips because of mechanical trip malfunction, delays on startups, and when you translate that into megawatt hours that they didn't produce to their customers, that was a significant amount of money. So on this 10-year plan, on this particular facility, we're working on this upgrade of the mechanical system into an overspeed with all the other things that I mentioned before. And basically, we want to really improve the reliability, risk mitigation, not to have a system that is going to be reliable and not going to give them spurious trips as the way the current one is giving them, and trying to reduce the startup time. That's a very important thing that we want to have in here, because every time they have to do, if you think about, these are reheat turbines. They're really big. Startup process can be in the hours time frame. And if you take that machine all the way to maximum governor, to overspeed trip conditions, and you trip it with your mechanical overspeed system, and it doesn't work, then you have to allow that machine to cool off. You have to wait for that to be able to work on that bolt, a mechanical bolt. Do it, fix it, come back, and then bring that back again. And since it's such a big machine, you have to be very careful with all the temperature expansion and be sure that all the warm-up cycles are going on. So you might be thinking about here of hours on the startup process just because that didn't work. And in many cases, when you have a mechanical overspeed bolt, you have to have 3 consecutive or 3 successful tests within the boundaries allotted for that mechanical bolt. If that doesn't happen, then you have to come back again. In this particular application, when you have an electronic overspeed, you even can trip your machine at lower speeds just to be sure that the electronic piece is going to work, and then you adjust your set point accordingly. That's significant savings just that at the startup time. So as you see here at the end, that's the 10-year modernization plan, where we have different solutions for this particular plan. One of those, as I mentioned, the electronic overspeed. But it goes into many things where we're helping this customer to fulfill and satisfy a lot of issues they have right now. They have problems with the boilers. There's an upgrade that's going to be there. We're going to work on the combustion optimization. We're going to do some life cycle upgrades. They have an IA Foxboro DCS right now running, so it's going to be an entire modernization of that control system. And also it's going to be an instrument asset management system that is going to be included for this. High performance graphics is a new thing that is going on right now to really give the operator what he needs and his tangible information that he can use properly. And also we're working with our cybersecurity team to help them with NERC compliance, and is a big trend today, and we're also sensitive of that, and we're working for our customers as well on that. And I think that's the end, and if you have any questions or comments, please go ahead.
Thank you, Hector. Actually, as you presented, we did get some questions come in. For those that do have questions, feel free to submit them now through the chat box. And the first question that I have here, Hector, is why should I prioritize turbomachinery modernization above other needs or upgrades or maintenance in my plant?
And one of the things that I would say is because, as I mentioned before, it's a big investment. It's a really big investment that you have in your facility. It's most likely the only one that you have. In many cases, it's the core of your process. And if it goes down, you're losing a significant amount of money, and your plant will go down. So that's what is one of the things that we need to focus, and it's everywhere in any plant. We have machinery everywhere that are the core energy transformation of our processes. So that's what I would say. That's what we need to really focus on standardizing or thinking on modernizing that particular piece.
Okay, thank you. And a final question. Who do folks contact to make this modernization process, to set the modernization process in motion? And what approvals are needed?
Okay, that's a really good question. And that, for you as our customers, anybody in Invensys can help you. If you're an old customer that has been with us for many years, you already know your sales executive that you're dealing with for many years that gives you the confidence of that person. If it's not that person, is the one from engineering that has been working with you in many other projects in the past. Any of those guys can initiate the conversation and enroll the proper stakeholders and bring all these people together to help you. If you are a new customer, I have, at the end of this conversation, we're going to have my contact. You can contact me. You can contact anybody from my team, anybody from the sales team, and we'll be more than happy to start the conversation on how we can help you improve your system.
Actually, we did get one final question, and we've just got time for one more. When implementing an electronic overspeed system, how many speed probes are recommended?
All right, depending on the standard that we want to have, the standard talks about having segregation between governor speed probes used for control and speed probes used for protection. So depending on how reliable you want your system, you can have a 2 out of 3 voting scheme. So in this case, you will have 6 pickups, 3 for your overspeed system or 3 for your control system. If you're just thinking about the segregation and the compliance with the standard, you can have 1 and 1 segregated, but obviously you're going to have a single point of failure. So if I have to recommend, and we're doing at that point that investment, I will recommend to having 3 pickups for control and 3 pickups for overspeed.
Okay, great. Well, we're out of time. Just wanted to remind everyone once again that we have additional webinars scheduled over the next several weeks. We offer 2 a day, so you can choose a time more convenient for you. The next topic, which is taking place in 2 weeks, is reducing total cost of ownership with intelligent marshaling, new technology to save time and money. To register, please visit iom.invensys.com/modernize. You can also find recordings of the previous webinars. We have a cybersecurity webinar that was just posted, as well as workflow processes that was just recorded, as well as migration. On iom.invensys.com/modernize, you can also find brochures, white papers, data sheets. So I invite you to visit that website. And finally, please feel free to connect with us on our Twitter page. We've got a Facebook page, YouTube, and LinkedIn. We also have a very active online community, so please check that out. And if you have any questions, please feel free to contact Hector. His contact information is here. And Hector, thank you so much for your presentation. You guys have a wonderful and fantastic day.
Thank you very much for your time.